Well, between the elite schools at the top and the so-called industrial arts schools at the bottom, a middle tier in the French engineering school hierarchy also developed in France, represented by the Ecole Centrale des Arts et Manufactures, or Ecole Centrale is how I'll refer to it. As Grelon explains, this school, founded in 1829, developed in Paris specifically to serve the evolving needs of a growing industrial sector. Indeed, but if we take a look at the unusual trajectory of this school, which was founded initially as a private school apart from the state entirely, we see that it illustrates the somewhat awkward positioning of the private industrial sector in relationship both to the state and to the small shop enterprises in France. Also, by following the experiences of graduates from this institution, we can illustrate how the category engineer gained, or what became stabilized, were two different meanings for this category over time, referring both to the graduates of engineering institutions and to a particular rank of work on the job. As Chronakis explained, one can predict the let's say, middle-level recruitment pattern for the Ecole Centrale by understanding both that the school had high tuition and that the entrance exam was not as stiff as those for the elite schools. By the middle 19th century, roughly half of the incoming students were sons of middle or low-level civil servants, as well as merchants and industrialists. But importantly as well, another 30% did come from the higher ranks of society, such as the families of large landowners or high-ranking civil servants, suggesting that the school was intending to compete with the highest schools as best as possible, but with a focus on industry. In the first instance, the school contributed to an expanding pool of civil engineers, and as the contemporary analyst Christelle Didier explains, a civil engineer was basically one who worked in the civilian sector. In other words, the civil engineer was defined negatively, and hence the class to which is referring is a bit unclear, because a civil engineer is one who is not a state engineer and who worked in the private sector doing, quote, civil works plus mechanics and electronics, end quote. The 3-year curriculum at the Ecole Centrale, according to Chronakis, was oriented more towards industrial technology than the higher level schools. The so-called Centraliens, graduates, or the students and then graduates, they spent less time on mathematics and more than twice as much time on physics and chemistry. The American visitor who, in 1839, to whom I'd referred to earlier, reported that all students did take descriptive geometry, analytical geometry, and mechanics, and even theory of machines. But in addition, they were taking general physics, chemistry, and I'm quoting, hygiene and natural history applied to the arts. They also took machine construction, industrial physics that included sections on dyeing and distillation, the motion of air in pipes, and construction of lightning rods. They took courses in industrial chemistry, analytical chemistry, architecture, and civil engineering, as well as mining and iron metallurgy. There were also special courses on steam engines and on railroads. No calculus was taught until much later in the century. As one might imagine, the presence and the elite status of the state engineers in France made life for the civil engineers more difficult, especially to the extent that they were seeking high status, for they were both less visible and less respected. For example, the Ecole Centrale's most famous graduate is someone about whom you've heard, a man by the name of Alexandre Gustave Eiffel, designer of what is in English called the Eiffel Tower, and I'll pronounce his name Eiffel for that purpose. As described by the science writer Vilma Barr, Eiffel held a double high school baccalaureate in science and literature, and then went on to chemical engineering to take over his uncle's vinegar distillery in Dijon. But a family squabble ended that plan, and he found himself joining a construction firm in Paris, where at age 25, he developed a new method for using hydraulic presses to sink piles for a bridge. Now, from an outsider's point of view, Eiffel was typically French, and that he worked from underlying principles, using theoretical work and calculation to guide the specifics of a design. As Barr describes it, he was, quote, an innovative engineer and developer of a process for textbook execution of a carefully conceived, theoretically sound plan, end quote. Eiffel established his own company and built a large number of metalworking shops with a specialty in wrought iron structures. Cast iron for these structures was too brittle. It lacked tensile strength. The high elasticity of steel, on the other hand, could produce too much sway in high winds. Wrought iron, according to Eiffel, combined strength with rigidity, and at the same time could be relatively light. He built long-span iron bridges all over the place, in Portugal, Hungary, China, and many structures in Paris. In one case, for example, he successfully predicted the deflection of the loaded arch on the bridge at 8 millimeters, predicting it theoretically before it was measured. He designed the internal bracing for the Statue of Liberty. As a leader in the private sector, Eiffel was also an aggressive entrepreneur. For example, when his company won the bid for a tower for the Paris Exposition of 1889, he invested a great deal of his own money in the project in exchange for a 20-year franchise to operate the tower itself and to open restaurants. But Eiffel was a Centralien. Throughout his life, he received relatively little recognition in Paris. He had not attended the Ecole Polytechnique. He was not a state engineer. His many accomplishments in industry were not grounds for election into the French Academy of Science. Perhaps this explains why, after the tower was constructed, and shortly thereafter a Panama Canal project on which he was working had failed, Eiffel turned his attentions to mathematically based science, seeking prestige in traditional French terms. He turned the tower, on which he had this franchise, into a multi-use testing laboratory, and he published research on aerodynamics, including flow over airfoils, research on meteorology and telecommunications. This, more than designing bridges or building a company or a tower, is what was valued in France.